Okay, 12.7, we're going to talk about experimental probability. And experimental probability is probability based on experimental data. The probability of an event happening is the number of times the event occurs over the number of times the experiment is done. Now, the difference between this probability we did before and this probability is based on theory. In other words, how many good outcomes over total outcomes. This depends on what the people tell you. Like, for example, a medical study tests a new medicine on 3,500 people. It is effective for 3,110 people. Find the experimental probability that the medicine is effective. Then predict the number of people in a group of 6,000 for whom the medicine will be effective. Well, the experimental probability on this problem would be the number of good outcomes, number of times the event occurs, 3,010, over total number of people, 3,500. So the probability for this event, I'm going to say P of E, is equal to 3,000 over 3,500. Now if we go divide that out, if I get my calculator to come up, so we're going to take and go 3,010 divided by 3,500. Enter. Let me get 43 out of 50, or 0.86. I'm going to put down. So that is equal to, so it's effective for 86% of the people. And now predict the number of people in one group of 6,000. So we're just going to take 6,000 now and times it by that 0.86%. So if we go on here, and we're going to go back to my calculator and take 6,000 times 0.86, and we're going to hit enter. So for those 6,000 people, 5,160 of those people, that would be effective for as you go through. Another medicine is effective for 1,183 out of 2,275 people. Find the experimental problem that the medicine is effective, then predict the number of people. So again, on here is the probability of the event to occur. It's going to be 1,183 out of the total number, 2,275. So if we go on our calculator and divide that out, 1,183 divided by 2,275, enter, is 13 over 25, which is going to be about 0.52 if I work that out. So this would be this was not as effective. It was only 52% of the people. Then it says predict the number of people in group of 4,500. Well, we're going to take that decimal, 4,500, times 0.52. So if we go back to my calculator, 4,500 times 0.52, it should be about 2,340. So about 2,340. Now I'm going to go back to this. How did I get 0.52 when the calculator said 13 over 25? Well, you could go in a calculator. You could divide it out and say, okay, 25 goes into 13 5 times, 125. 50 left over, and 25 goes into 50 2 times, and that's where I get the 0.52. A simulation is a model used to find experimental probability. So simulate the correct guessing of true or false answers. So there's a heads, tails, tails. Heads would be the right answer, tails would be the false answer. And so if I went here, let's say, how many questions was there? So let's see, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So here's a simulation for 50 questions. And what they said on this simulation, they said that heads is the correct answer, and tails was the incorrect. So how many did they get right? Heads, they got 2, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So they got 22 correct out of 50. So the odds of getting it correct is 22 out of 50 on this simulation. And now it says in example 2, compare the experimental, this is experimental probability, with the theoretical. Now, if it's a true and false question, what's the chance of getting it right? 1 out of, so theoretical would be 1 out of 2. So our experiment means that we did worse than we thought we would on here. If you try the experiment 100 times, what is likely to happen to the experimental probability? If you kept going more and more examples on here, this experimental probability is going to get closer and closer to 1/2. In other words, sometimes you're going to get more than 50%, sometimes you're going to get less than 50%. By the time it's all done and over, it should get closer and closer and closer to the 1/2. And let's look at here. It says, now a student randomly selected 68 vehicles in a parking lot and noted the color of each. Use the results to find the experimental probability that the vehicle chosen at random in the lot is the given color. What is the probability as a percent and to the nearest tenth of percent? Okay, let's look at, I'm going to do one. Let's say red, and there's 68 vehicles. In red, there's 12, so for number 1 here, it was 12, probability of this event happening. I'm going to say probability of red is going to be 12 out of total number of vehicles, which is 68. Now I'm going to divide that out on the calculator. So I'm going to go with my calculator, and I'm going to take 12, if I can get it to type, divided by 68. Control Enter to get the decimal. 0.17647. Excuse me. So 0.17647. And now the directions say as a percent to the nearest tenth of percent. So here's my tenth. So this would be 17 point, now if we're rounding, 17.6%. Now I'll leave the rest for you. Thank you.